languages. You love them, you hate them, and for many of us, it's the medium that we're best at communicating in. And we love talking about them. I'm Jas.
I'm Mike.
Hi, Mike. This is a podcast series where we talk about programming languages, what we love, what we hate, the languages themselves.
So what's our topic for today, Jas?
How about regular expressions or regular languages? Just to light a fire amongst our
yeah, I guess so. I guess the word regular, right? Kind of a reference to what is it? Chomsky's hierarchy of grammars, right? But has surprisingly little to do. Sorry?
Right, okay, I was asking whether that's where we get regular from.
Well, so there's regular grammars, right? And regular grammar is there's a very particular technical definition, which I think goes back to Chomsky's hierarchy. But regular expressions are kind of, like I think the term that is there because of that reference, but they're not actually restricted to regular languages, right?
Regular expressions themselves as they're used today are not, for sure.
Yeah, and I guess, kind of the interesting thing about regular expressions is there's, we talked about love-hate relationships. Many programmers have this love-hate relationship with regular expressions, and kind of, I'm probably gonna mess up the quote, but, oh, you have a problem. I know, I'll use a regular expression. Now you have two problems. And so it's always kind of amused me that people are so divided on regular expressions, and yet they keep making their way into modern languages.
But do they? Like, so take Java, for example. So Perl, famously so, but languages like Java have regular expressions, but they're not a special syntax. They're sort of, a library edition.
Yeah, and so it's part of the standard library. They're maintained by the language people, and they're a topic of debate amongst people who put out JSR, Java language proposals, and yeah, Go does it via library support, and so does Python. Python you combine raw string syntax with a use of a particular library, but it's kind of, since they're part of the standard library, they're kind of seen as a useful thing for people to have, right?
I see.
And I think you're right. It does go back to sorry,
and one that you can sort of lean on to be there in whatever language, in many of the languages that you're in.
Yeah, and I think it's kind of people are used to using them in one language, and that's why they're used. So before a large chunk of developers made their living gluing together networked services, a large chunk of developers made their living working on kind of Unix systems on top of network file systems, and on top of the Unix they used sed and awk and Perl. Perl got its regular expression syntax in some degree from we're piping together processes that print out kind of tables of things that and regular expressions are great for pulling cells out of tables and maybe transforming them in some kind of cookie cutter ways and spitting out the result as another table, right?
I mean, so it's now it's almost an embarrassing episode in my past, but I got my start in life as a sysad at a university, and part of the one of my superpowers was that I could wield I could wield regular expressions in a way that would startle in a maze and occasionally explode things in fantastic. And there was a fantastic book by Jeffrey Friedel. Now we should check whether that is actually the name of the book, but it was a treatise on regular expressions.
Sorry, what did you think the name of the book was?
I don't remember the name of the book, but the author is Jeffrey Friedel on regular expressions, or something along those lines. Is something that we will definitely have to look up. But it was a sizable book, but it covered so much ground. And I think over a period of like 2 weekends, when I was an undergrad, I read this book, and it materially changed, my skill set as a system administrator, because I was able to glue, like you say, right? Like I was able to glue random pieces, random services together in a way that anybody else would require large amounts of code to do. But he was Jas's one-liner, stringing together Perl and awk and sed, and like look, magic happened. Like this is not something you want to ship into production, but like in an emergency, this was amazing, right?
Yeah, and there's a kind of aspect of that kind of Unix sysadmin work that is similar to building these Rube Goldberg machines, where you hit the dominoes and then that hits the hamster wheel and wakes up the hamster, and the hamster runs and bumps the toaster and that kind of stuff.
Wait, so you have seen my work then?
Yeah, I don't think this was restricted to New Zealand universities.
But do you think that it's that history that taints regular expressions? Like essentially, one of the things that we said here, I mean, one of the things that you said was, people hate it because there's some reason, but there's also utility, and like, is that where this tension is causing people to have like such a strong reaction to regular expressions?
So I think. So yeah, there's like we talked a little bit about history, like what was the ecosystem that spawned regular expressions, and why were they kind of essential tools in Unix sysadmins kind of toolkits at the time. And yeah, like familiarity, like if you're producing a new language, you need to one quick way to bootstrap your language community is to make it appeal to an existing language community. And part of that is, I reach for a tool, it's in my toolkit, right?
Right.
And so, and having, regular expressions available in the language is one of those. But the other part of it is that, regular expressions are better for certain tasks than the alternative. Like if you've written string processing code in C and you can turn 30 lines of dense C code into a one-liner in Perl, and that happens every day,
right.
You kind of fall in love. Going back to your experience with this book, like,
right.
like I discover I have superpowers.
There's many reasons to fall in love. One is succinctness. This is why we've gone from I love you to ILU. But what I seriously mean there is, the nice thing is that because it is a subset of the language, the amount that you need to understand in order to sort of picture what this string processing unit is doing is much less. Whereas, if you hand wrote a recursive descent parser by hand, let's say, like, okay, it's doing the same thing. It might even be doing it, in some cases more correctly, or is able to handle more corner cases. But like now, there's like hundreds of lines of code that you need to read.
Yeah.
Whereas regular expressions, just say like, there is an engine underneath here, but like this is the thing that you're trying to get to.
Yeah, and I think And so for certain kinds of tasks, excuse me, the succinctness of regular expressions, being able to express an idea, they're very readable. You know, you can use
did
them.
you just call regular expressions readable? I know I led you to that, but like you were the one that had it.
Well, I'm talking about like why, you know, sometimes when you're you know, when you're learning a new technology, you're like, oh, I have a problem, and somebody says this sounds like a good tool for the job, and you're not exercising in your own mind like what is the correct tool for the job. That's coming from outside, and so, you know, maybe that person is correct, and you're like, oh, this is great, it's the perfect tool for this job because somebody has already. But then you go through a phase where you're like, oh, I've got this new tool, I'll use it on everything, you know, hammer nail kind of stuff. And but and you haven't, you know, like precisely calibrated your, is this the correct tool for the job? And yeah, regular expressions, they're not the right tool for many jobs. Should we actually just go to the first? We have slides.
Oh, we have slides. Amazing. Let's do a slide. Why not?
So for for people who are listening,
I assume that this is the most readable regular expression you were able to find.
Well, no, it's not. It's the most readable, non-trivial, where you're actually kind of using features. And so, you know, if you're familiar with regular expression syntax, you'll recognize that there's 3 regular expressions here, and the top one is matching some digits dash some more digits dash some more digits, capital T, and then, you know, 3 more groups of digits separated by colons. And so, you know, it doesn't require, you know, you look at this a little bit and you're like, oh, it's matching an ISO 8601 date time, you know, year, month, date, then a T, then hours, colon, minutes, colon, seconds, right? Okay. And, you know, this is readable. It matches a lot of things that aren't valid dates, right?
Right.
You know, like it'll match 99 seconds. And it, you know, there's no optionality to the seconds. And you can match a month that isn't, you know, 1 through 12. And you can even match a month that's 0. So there's, you know, like it's overmatching. But if you know a priori that what you're doing, that what you're getting is, it matches the format, then it lets you pull out the pieces, right? And it's readable, it's succinct. The second one is just a modification of the first, but we've got open parenthesis, question mark, colon, block around the seconds. You know, the seconds are optional in a date time. And, you know, there's a question mark at the end after that question mark, colon. And so that, you know, now we're getting into like some, you know, non-capturing groups. You got to kind of understand the distinction between capturing groups, when do parentheses, you know, when do parentheses mean grab this and make it available, and when don't they? And it's kind of awkward, you know, open parenthesis, question mark, colon, colon, and then, you know, the parenthesized /D plus, you know, you've got 2 colons adjacent there. Yeah. One of those colons is a meta character. It's part of the regular expression language, right? You know, because open parenthesis, question mark, colon means non-capturing group. Right. The other colon is, well, it's an a colon. Character. Yeah, you know, like we separate hours, minutes, and seconds with colons, and so that's actually. But, you know, it's a little bit confusing, and our whole thing just got a tad more complex. And finally, there's this big regular expression which says, oh, you know, we're only going to accept 4-digit dates, and our time, it can be 2 followed by a number 0 to 3, or it can be, you know, 0 or 1 optionally, you know, optionally then followed by a digit, right? So, and so we're saying what you're allowed with is hours, and we're doing that similar trick for the minutes and seconds. And so we're putting a bunch of validation logic in there. And you can clearly see here's a trade-off. The first one is readable, but it rejects things when you don't have the seconds. The second one has some confusion because sometimes a character is what you want to match, and sometimes it's a meta character, and you got to know that difference if you're going to get it right. And the third one, well, you know, it saves you from writing matching code afterwards. It saves you from writing all that validation logic afterwards. But the regular expression looks pretty gnarly now. It's no longer obvious, that it's no longer obvious what
what it's actually trying to do.
Yeah, but by tweaking the regular expression to reject things you don't want, it's less obvious how it matches things that you do want, right?
Right. So there's two questions that I see immediately arise there. One is, one way of tweaking this into a better state would be to say, hey, we made a mistake in the syntax that we have chosen for regular expressions. And so, we should probably make it so that the colon, like one character introduces an operator and we don't mix and match them, for instance. There's many ways that we could do this. Allow, Perl, for example, has a /x that lets you sort of use white space that is, non-meaningful inside a regular expression, and now you can lay out your
regular expression flag. Yeah,
that's right, exactly. So that's one set of things one could do. There's another thing that is sort of implicit in what you're saying, which is, we do the simplest most thing in the regular expression, the thing that the regular expression is good at, which is pulling parts out. The grouping expressions here that you can use to pull like important parts out, and then you fall back into the host language to say extended logic that makes sure that the digits are like here. Like part of the reason why the third statement is so complicated is because time happens not to fall cleanly into into two digits, right? Like there's a so let's touch on both of them, right? So do you think that improving the syntax is the high bit, or do you think that I'm touching both, I guess. Like which of these two is the way to go?
Well, I think let's go back to why are regular expressions good when they're good? Because you don't have to write string processing code, right?
Right.
And there's an element of if you're going to put all your validation logic in regular expressions, that's string processing code that you don't have to write. And the impedance mismatch, the reason it's hard is because what you're trying to do is in string processing, you're trying to reason about ranges of integers.
Right.
And so and a regular expression, you can share it, right? If we have the simple regular expression, then anybody can use it to match values that are good. They can pull out things. Then you have to separately share the validation logic. Well, now we've got like shared validation logic and shared definitions and shared extraction. That's great. It sounds like you should probably just write a date class. And the reason why regular expressions aren't used to parse dates, even though this is this example, it's pretty easy to like this is a pretty nice example that to showcase regular expressions, is because languages have date classes that do that for you. And so if a format and kind of the quality control checks and like we want to parse tolerantly, so we can say give good error messages, hey, your minutes part isn't good. You got to pull out an invalid minutes part to be able to determine that, right? And so kind of these libraries, if something is really a well understood format, it's almost like, well, if it's a simple, well understood format, you could use a regular expression, but you probably actually have a better alternative available to you.
You seem to be arguing that whilst regular expressions are shareable, in many cases, you're better, like the unit of sharing should be something where, maybe inside the
maybe it uses the regular expression internally.
Right. But like the unit of sharing should maybe not be a regular expression, because you're unable to easily, pack all of this extra, sort of checking and validation logic.
Yeah.
RFC, is it 3986, the URL parser, the appendix contains a regular expression for parsing URLs. I think that you had an
Appendix
example for
B,
URLs.
I think, if I recall correctly, yeah.
Appendix B.
Although
I think that you and I became like intimately familiar with that particular RFC. At some point.
Just for the audience, that RFC has since been superseded mostly by url.spec.whatwg.org. So yeah,
correct. Which is actually the point that I was going to try to make, right? So like one of the things that I saw people do as a result of it being in an RFC is that people would copy and paste that that regular
totally
expression.
Totally never done that, not me.
For those in the audience, Google Kaha/URI.js. One of my former colleagues also spent a large amount of time pointing out all of the errors, Mike, that we made in that particular parsing library. Just saying.
Yeah.
But again, like that evolution occurred. Why? That evolution occurred because the semantics that the users of URLs had changed over time.
Yeah.
But regular expressions could not. The disadvantage that you have with the WG version is that it is like the spec A is in prose. I mean, it's a set of steps in prose, but also, if I remember right, is not expressible as a single regular expression.
And so I think the Appendix B specification probably, so my recollection is that the early URL RFCs, they were trying to be very general as far as what is a host, because the standards community and was arguing about that. And then there was 3986, which says, actually a host has kind of this syntax, and we're because those writers had experience about like HTTP proxies and all of and they're the kind of what is an HTTP host was kind of well understood. And then I forget the timing, whether IPv6 was before or after that, but then IPv6 came along and kind of like, you've got square bracket hosts, and I think that introduced some corner cases, and so these kind of things, the internet has kind of stumbled along despite many different servers and user agents having subtly different understandings of what URLs are,
right?
and lots of proxies kind of making assumptions that aren't allowed by any specification, that are explicitly forbidden.
Right, any mechanism to do addressing. So emails are an excellent example, right? They're easily matched using a regular expression, right?
Should we go to the third slide?
Sure, let's try that.
Well, actually, I guess we've got the second slide since we're on the topic of URLs. So the second slide is /http://example.com/example.com/foo// So what could possibly go wrong with that? Maybe this regular expression is used to say, hey, if I'm handling a response, if I'm handling a request for a particular resource, send it to this servlet instead of that one, or something, right? There's an awful lot of things that can go wrong there. First, like it's kind of nice because it looks like a URL. It's obvious like what the intent here was.
Right.
Yeah, right. And so that seems like a win for regular expressions, but there's a little bit of awkwardness, right? we have to escape the slash
Right.
because that's a URL meta character. And like domain names are allowed to be case insensitive, right? And that's not reflected here. Paths aren't supposed to be case insensitive. We can't just slap an I on it and make it
right. You can't put the I
forever.
as a flag right at the end.
Yeah,
right?
yeah, like at the end, right? We
Right.
can't just make this regular expression globally case insensitive, which is an easy thing to do syntactically. So that's kind of awkward. And then there's the dot, example.com. Like,
Oh man, the number of security bugs I've noticed as a result of that is pretty magical. But like,
yeah.
you should explain. You should explain exactly what bug arises there.
Well, dot could be any character.
Right. but it just happens to be the case that dot
matches any character. Yeah, but dot is a meta character in URL authorities, in host names, basically. And so that's a potential source of confusion. There's also the problem that this regular expression isn't required to match at the start of a line. So unless you're using the right matching method, somebody could send you a URL which has a question mark, junk equals something
with like right.
And so they give you one URL, your pattern matcher matches part of the URL that you didn't expect, and so routes this URL that the servlet wasn't expecting. And so which and hilarity ensues, often with security consequences.
They're like we run the risk of putting too much blame. Like in a lot of cases, we should have blame, but like it's possible to make semantic errors in other kinds of parsing code. The thing that is
you're right, like in a
C. Right.
Yeah.
The thing that is working against the regular expression here is that it looks correct.
Like,
your eyes, a human reader is basically glancing over that and assumes that they understand what the thing is going to do. Right.
Yeah, but I guess the overarching point is like the things that you would do to correct these errors make they like you're forced into this trade-off between readability. Like if I want to make the example.com case insensitive without the foo making the foo case insensitive, what do? Do I do square brackets big E little b e, square brackets big X little x, and so on and so forth? Suddenly now, like I can't. You
can't eyeball
scanning English or Roman letters rather don't help. And similarly for the dot, and so you would, again, if you have a library that lets you express predicates over URLs, that would probably be a better choice. But unless that library has syntax support, it's probably not going to get as succinct as this regular expression. Right.
For what it's worth, I think that I owned I can't remember what product it was. Maybe it was mailxgoogle.com. For a long period of time, because I just assumed that people would make these kinds of errors, and that it would be a place that would receive traffic every time somebody made a mistake like that. So going back to email addresses, are they similar problems with email addresses?
Yeah,
but it implied that was not the case, because we see emails being checked with regular expressions all the time.
Right? We know emails, we use them, and so like
I know how to recognize one, surely.
Yeah, who can't cook up a regular? Yeah, who can't cook up a regular expression to match an email address from the top of their head? And it's like this slide /w plus at, and then character set /w dot plus, and then literal dot, and then com, right? This is going to match a regular expression, and it's going to grab the parentheses are in there. I didn't mention them, but they're in there to
remind me what the /w does.
/w is like a word character, right? And so this is actually one thing, like what is a word character? The entire world does not run on ASCII.
Wait, what are you saying?
and going back to the 100 things that programmers know about names that aren't true, right? um, and yeah, so /w in many regular expression engines means like A to Z, 0 to 9, maybe underscores and $signs, kind of things that were allowed in old C identifiers and not things that weren't, right? Um, and so it's kind of tuned for parsing programming language identifiers, but when you use it for things like human names, it'll kind of work maybe for people in your office if you're in an English speaking office, but it'll fail pretty hard as soon as you step outside that group.
So is there consensus amongst different regular expression engines? So there are different regular expression engines. Do all of them basically agree that /w, the set dereferenced by /w is the same? I don't believe that to be true.
Well, yeah, and so I guess this I think some I could probably have quoted chapter and verse to you, 5 years ago. I believe many regular expressions have moved in the direction of like, we'll have a Unicode flag, and the Unicode flag kind of means that like,
we will use the Unicode's definition of
because like there's letter characters, right? And right. Letter characters include Chinese characters and kind of, if you're going to make a word out of things, it's kind of those, but they don't include many of the for example, Arabic has lots of when you're writing Arabic using a computer, you need to enter these joining indicators that explain how letters join, and my vague recollection is, like, don't quote me on this, but those are not part of the letter group. And so if you're going to define a word, you kind of need to say, word joiners and letters. And so, but the Unicode flag turns on some of those and not others. And so it kind of lets you do a better job, but not great. And
so again, in defense of regular languages, or regular expressions at least, like those are choices that you would have to make if you were writing a hand-rolled parser too. One of the nice things here is that at least some of those groups of choices have been made so that every person that is rolling out their own parser doesn't have to do this from scratch.
And the Unicode people, I forget whether it's UAX 13 or 17, but the Unicode people have said, like, kind of, here's how to interpret these categories in the context of like programming language identifiers, where you want people who use, like, you want to be people to be able to write programming language identifiers using their character set, right? And but and so, like, if you can have these, it's you can have kind of these joining characters, and there's kind of a state machine kind of described that says, here's how you do a maximal left to right gather of of an identifier, and you can express that as a regular expression. Probably not super readable, but like, if you've got a blazing fast regular expression, it's not a bad way to tokenize a language file. If you're going to do something with human names, you need something a little more complicated. And so and for that very reason, the email specification, what is a mailbox, kind of what is the address specification part of a mailbox is actually like much more complicated than in this slide. Yeah, this is an eye chart. I'm not even gonna try to explain that.
It's a lot. So I'm mindful of time here. A lot of this is poking on, hey, look, the syntax for regular expressions makes this difficult. there are other ways of, I mean, you mentioned it yourself, right? Like there's a state machine that the Unicode authors had in mind. And that state machine, if we go back to computer science classes that we've had, like, regular expressions are representable.
Yeah.
There's some kind of finite state machine underneath
Yeah.
it. I know I'm like brushing over, regular expressions aren't regular anymore. And there's like a whole bunch of like things that I'm brushing over here.
But when
like,
they are regular, not every regular
regular
expression is regular, but when they do define a regular language, yeah.
We can represent them visually. And maybe that, like, does that come to our rescue?
Yes. If you wanted to match a CSV cell. And so this is kind of, going back to regular expressions roots as tools for tabular data processing, tying together tools that stream tabular data to each other, and not, like, this doesn't depend on, it doesn't depend on, like, humans are more complicated than you think they are. Yeah, like, there's
wait, I can't match human beings with a regular expression. What are you telling me? Not even a irregular regular language?
Yeah. And so yeah, this is for matching CSV, and it's it's a CSV, comma separated value files, right? It's, if you want to save a spreadsheet or something as data, then you can save it to comma separated values. And the idea is, you have text and you put commas in there, but when you've got a comma in your text, you need to put quotes around it. And when you have quotes and commas in the same cell, you need to put quotes around it and then double up the quotes. And so, the CSV grammar is regular. It is a regular language. And this regular expression does a great job of just, allowing you to consume a cell. But, it's kind of hard to read. Like, it's dense. And it's probably less dense than, if you were to write this in an imperative language using for loops, right? But we can actually visualize. The nice thing about this regular expression is we can visualize it in a way that we couldn't visualize imperative code.
I think that is a very,
which is a very nice property. Yeah.
Yeah.
And so, if people look at the Stack Overflow links, the person who answered that, I don't know their name, put together a beautiful kind of railroad style diagram of what this is doing. And it really helps you understand kind of like the complexity of what they were dealing with and how they dealt with that. But, like, the regular expression allows you to express that state machine, but the actual, the simplicity isn't apparent in the syntax. And it's not apparent, like, you have to step outside the syntax of the regular expression to kind of to get at that state machine.
See it.
Yeah.
So I'm gonna transition using that as a jumping point. So essentially, you have regular programming languages which are highly expressive, and by which I mean, you can embed in them all kinds of
and by regular logic here, you mean normal, kind of. Yeah, right. Familiar. Yeah.
You have languages which let you do all kinds of things, but turning that back into a railroad diagram, even if the thing that you wrote in that Turing complete language was merely a a railroad diagram, representable system. If you wrote a finite state machine, it's hard to like take that and like sort of go backwards back into something that is visualizable. On the other hand, you have like regular, like actually regular languages, which are of course representable as a finite state machine, which have this very nice sort of human understandable representation. By the way, I did spend a chunk of time in halfway in between these two worlds, where I would force regular expressions that weren't quite regular in Perl, for example, to do increasingly insane things. I don't remember. It was the Fun kind with Perl mailing list, which would where somebody produced, this is a little bit of a fudge, but like they would produce a regular expression that would recognize only prime numbers. right? Like, which,
Yeah.
like, which, if you go ask your theoretician friends, like, hey, are prime numbers regular? Like, they will look at you strange. And, there was a,
And the answer is no.
but there was a like nifty
Yeah.
little trick that was done in order to
Using
make that,
doing bad things with back references.
Well, doing bad things with back references, but also representing the if I remember right, representing the number as a sequence of ones of length, the number of
kind of piano style, right?
Exactly. And then now you basically would try to do, using back references, matches that said, can I divide this string into like a complete match, right? Essentially, is how that trick was done. And then like relying on the backtracker to just go back and then
and for the audience, regular expressions, one of the things that people say about them, some regular expression engines, they're linear time, right? The amount of work you have to do is proportional to the length of the string you're matching. But obviously, no correct prime number algorithm, is prime thing is going to be linear, unless again, complexity theory, not my field, but is that your vague understanding too?
I don't think that last statement is correct, but like I think we should pull out of this part of the of the topic. But the expressivity of the regular expressions, I think, is an interesting point, right? So the different programming languages implement regular expressions differently. They're also librep and standard regular expression libraries that you can sort of link into your programming language too. And one of the ways in which they vary is, of course, is the semantics, is the expressivity. Do you get back references? Do you get a negative look ahead? We should have a discussion on why a regular expression engine might choose not to provide candy to its users.
Yeah, and so I think I guess you mentioned the idea that I have a string and I can match it in linear time is very attractive. That gives you nice performance guarantees, and it means you can use it to vet strings from untrusted sources, right? Untrusted attackers that might want to deny service to your users, right?
So that's regular an interesting point. So I could,
service.
if I knew that you were using a regular expression, I could send, as an attacker, send you strings that cause the worst behavior on the server side.
Yeah, and just suck up CPU so that your server can't process other requests while you're trying to decide, is this a valid ISO 8601 date?
right.
And on the kind of code that you would write in an imperative language to match, is this an ISO 8601 date, would almost certainly not be backtracking. But sometimes, well, I guess actually most people, for the ISO 8601 date, you would have to try really hard to write a bad a regular expression that's susceptible to
I am sure that people succeed at writing very bad regular expressions for even very simple things. I've certainly seen the most trivial example of this is a dot star star, right? Anytime you have multiple be greedy and then back off, and then the outside can also be greedy.
And that particular pattern is that particular pattern is possible to solve this in the library implementation. But if you're not doing a state machine representation, it doesn't just the linearity doesn't just fall out of it. It's kind of, you have to do all this reasoning about epsilon transitions and stuff. So I guess your question was about are there subtle semantic differences? We've talked a lot about regular
Like,
expression syntax and the
right.
limitations there and trade-offs, but we haven't talked about. Yeah, I guess the biggest question is, what does dot mean?
What does dot mean?
Which,
I thought that
yeah,
that would be surely that standard across
yeah, it's
all
one
the.
character,
It's
right? It
exactly,
just
yeah.
match
How
any
hard?
one.
How,
Yeah.
how hard is one character?
Well, what's a character?
Surely a single byte. That's a character, right?
Yeah, going back to Unicode, like a character, is it a code point? Is it a scalar value, which is kind of like some code points, but not dodgy ones? Or is it in Java, like a character is 16 bits, right? A code point is two of them. Does dot mean if you're matching, if dot is matching a Unicode surrogate, one of those Unicode code points that represents half of a supplemental code point. Does dot match one of those halves? I mean, that's awkward. But also right. Awkward is I've got to match, like I want to match a grapheme, right. Like an emoji, many emojis. Like I think polar bear is like, if you have the my 9-year-old would be able to tell me off the top of his head. If you have a bear followed by like a zero with joiner followed by like a snowflake emoji, that's a polar bear emoji. Polar bear. Yeah. If you have like the flag followed by like some country code, right? Yeah. Sorry.
Families in particular are beautifully represented in Unicode. Like you can do math on families by adding or removing like individual characters from the emoji version, right? Which
and I think there's an element of like, hey, we're a standards committee. Why aren't we designing a programming language?
but in this
I mean, I understand, like that you want to emojis are very important to how people communicate today, and it's really hard to say no, we're going to have like the poop emoji, but we're not going to have a polar bear emoji, because polar bear is kind of awesome, right?
Yeah, is frozen poop a thing? Because poop, zero joiner, snowflake.
I will have to I'll send I'll write a letter to Cat Momoy, who I think was actually the poop emoji champion at anyway, like no like weird reminiscing on Unicode stuff. So back on topic.
My sorry, before we get back on topic, my favorite Twitter person to follow is Fake Unicode, for exactly this kind of insight that I get. I mean, to be fair, the Unicode spec is perhaps one of the really beautifully written specs. Like I mean, I'm being completely sincere. It was just so much thought went into how systematically it was written. Doesn't stop me from making fun of the task that they have taken on, right? Like, of course they're going to make like interesting. It's like a
hard
difficult
task, and those folk are, doing great work. Yeah, but on regular expressions, it's these questions. What it goes back to, like, languages represent strings internally in different ways. Rust and Go and most C++ code. Kind of a string is kind of well-formed UTF-8, right? Right. You hope, but you use strategic checks to kind of enforce that invariant. In many other languages, UTF-16 is kind of a good trade-off between memory footprint for strings and then in older languages that pre-existed, supplemental code points, they thought they could make do with UTF-16, and they were just wrong. But yeah, so I think the definition of like what is a character naturally differs, and programmers, and it's a hard task. Like, do you go with programmers' intuition of what a character means in your language, or do you go with some abstraction like grapheme? And I think the answer is really, are you working on programming language identifiers, or are you working on human text?
I
Yeah.
mean, so that's an interesting point. So basically, that means that I can't rely on, if I understand regular expressions in a language, like, a large number of people's intuition would be that, I can carry that knowledge across to a different language. And maybe a lot of things, I guess in that sense, it's similar to strings or to numbers or to other data structures that, we've talked about or we're going to talk about.
Yeah.
Where, like, yeah, I understand integers in one language. I think that, I can use that intuition in a different language a lot of the time.
Yeah.
But, when I go wrong, I go catastrophically wrong because, some of the intuition that I've carried across, is very wrong. And I think that, similar things apply to regular expressions too.
Yeah. And I think, regular expressions, part of the semantic differences comes from, we're trying to solve two very separate problems, like a quick and dirty tool for, breaking structured text apart so that we can process it. But it's also turned into this, like it seems like a really good tool for natural language processing. It just isn't. And so the kind of things you use to, like, oh, we've got people writing all this natural language processing code in regular expressions, like if you're trying to make a web page more dynamic, all you have is JavaScript. Your best tool for string processing in JavaScript is JavaScript regular expressions. It's, why would you, like, that's a natural,
it is a natural thing to read.
But I think this gets at one of the, going back to why are programmers frustrated with regular expressions? What's behind that now you have two problems thing? And I think it's that, you get an 80% solution with regular expressions and you're like, okay, I've got this corner case. How do I solve it? And you hit a wall.
Right.
And to get from 80% to 85%, you kind of, regular expressions, they don't degrade gracefully. I
mean, that's a very interesting point, right? That means that you're like, it's the siren call, right? Like, by being so easy to start with regular expressions, lead a programmer down a local minima, like there's like a crap attractor, where if that is true, and I can see reasons why that would be true, like that's an argument for not giving programmers a tool that you think is eventually going to hurt them, right? Or do we not take a role as the language designer of taking things away because we know that eventually a developer will hurt themselves? This is it's a dicey place to end up.
If the programmer is only hurting themselves, that's different from the programmer hurting their user. But I think, it is a hard thing. Do you make it harder to do what regular expressions are good for? Kind of processing structured text that is in protocols that were designed to be processed by regular expressions to some degree. And I think and how much is having regular expressions inhibiting experimentation into what are good ways of processing natural text in programming languages where you're close to the client, like in a browser or, in a mobile device. And I just don't know the answers to those.
It's an interesting one. We never quite hit on the other kinds of expressivity that engines might take away, like back references and negative look ahead, but performance has got some aspect to play in that, right? Like, one of the things that you mentioned, I guess, was you don't want to allow a regular expression engine to end up in the worst case because you know that the inputs that they are going to be processing is attacker controlled, and the attacker might be able to do something pretty bad with it. There was oh my goodness, I can't remember the name of the author, but a master's thesis on how to analyze regular expressions to work out whether the worst case behavior
this
possible or not.
Is this kind of, you've got regular expressions that may use kind of things like look behind and look ahead and back references, and you're trying to compute a counterexample.
A counterexample that causes the worst case behavior. It was really good work. I'll drop a link. Mike, we're running short on time. Definitely want to squeeze in a good thing, bad thing. Prepare yourself. These are short, snappy answers on things that we think or you think are a good thing or a bad thing. Back references in regular expressions.
Probably a bad thing. There's a very few, very few times that I've thought, hey, back references are the right time for a job, right tool for the job, and I've done a lot of like dumb things with regular expressions. Yeah.
You're breaking my heart, man. I can use back references to do amazing things.
Yeah.
String representation of a regular expression.
So string representation of regular expression, like, where
like writing regular expressions as, concatenations of strings.
Yeah, okay. I guess sometimes you want to share part of a regular expression. You want to, define one part and reuse it. Like the person who came up with that giant email regular expression probably was concatenating a bunch of strings together.
Right.
I mean, in some languages it's awkward because, like, /b means backspace.
Inside the string.
In a string literal. And so you
Right.
have to say /b to mean like word boundary, right? In a Perl style, in Java, for example. Python gets around that with raw strings. I think it's solvable. And I think IDEs can probably detect most of those problems these days.
So you're fine with it?
I mean, as long as as long as there's some way to give a hint to say, I'm doing regular expression stuff here, kind of IDE, like double check me.
A ASCII representation of a regular expression, by which I mean like ASCII art representation of a regular expression.
Oh, like
if
we were gonna do the railroad diagram,
but as a picture, like, yeah.
I mean, I talked about regular expressions hitting a wall, and like what are some things languages have done. I think Raku, which is Perl 6, right? Like at some point the community is like s/Perl6/Raku/G. I think.
Thanks for that.
So I think they decided, regular expressions are great for some things. When you get bigger, like, let's just allow you to have grammars, and that allows you to say, well, you could, with a grammar, you can name a production, and that solves the reuse part. I think that seems a more natural way for me than ASCII art, but like, why not, like, if an IDE plugin can take your regular expression and just like dump an image next to it, like that seems one way you could provide visualization without, like, ASCII art. I'm no good at. I put it in my comments. It's always a maintenance hazard. It's me trying.
I think that there's oh man, I'm gonna forget her name. Another Twitter user that I really like, Kate. Kate. Her name is Kate.
Kate does things or something.
Kate does things. And she has, like, oh my goodness, no, does things.
That's probably wrong. I think it's something
probably
like
wrong.
That,
yeah. But having source code that has that prints out visualizations of itself, I think is wonderful. Case sensitivity as a flag.
I think again, this is a thing that I think Java and many other regular expression engines since then, I think PCRE, allow for scoped flags. But again, case it's one of those things, like, if you live in an ASCII world, sure, case means one thing, but in when humans are complex, like Turkish and what is it, Azeri, languages have different case.
The Turkish eye is famous.
In the security engineering world, it's a gift that keeps on giving. So yeah, but I mean, I think I think when you're doing case conversion, you have to be cognizant of, am I dealing with human language text? Am I dealing with something that's, you know, meant for machine interpretation? Yeah, I think it's a red flag for me in code.
Last one, regex or regex?
I can't say the latter. So
I don't think I can
I have
either.
a strong opinion here. I just say regex. Yeah.
Fair enough. Sounds good, Mike. This was a really fun conversation. I learned a bunch of different things. You came armed with slides. That is awesome. I think we got through a few of them too.
I mean, I'm doing homework now. I mean,
yeah, I know.
I did not sign up for this.
This is awesome. I'm gonna have to dress up in a suit and tie for the next one. So what did we cover? We covered a whole bunch of things around the impact that syntax had on regular expressions. We didn't quite touch on what a regular expression is, other than hinting that it might be something to do with regular. I think that that's fine. We covered a little bit around.
There's great write-ups of like what a regular language is online,
and that way we won't fudge it.
Yeah.
There are a bunch of things around what the impact that the semantics of regular expressions have. And then we covered also that regex, not regex, which I think is the entire ground as far as regular expressions go.
Yeah.
Thanks so much, Mike.
Great time.
Great always chatting with you. We'll see you guys the next time. We're hoping to do this once a week or so. So same time, once a week. See you next week. Catch you later.